Good evening. Are you sitting comfortably? Good. I'm sure you all like AM radios, for it's all about making one, albeit a small one, tonight. So, let's start tonight's episode on the Technomora channel. Parts together that I would need for the project. So obviously we have the resistors here, then we have the electrolytics, and we have a few trimmers, multi-turn trimmers. What else do we have? We have a few mylar capacitors, and then we have a few active components. We also have a battery holder, or connector, really, a 9-volt connector, as you can tell. And what else do we have? We have a speaker, so a 4 ohms 3-watt speaker. We have a small used tuning capacitor, which you see here. I don't know if you can see the details, but I can. So I'm not sure it's good, but I think it is. So this is what we're going to use to design the tuning side of the tuner. And then what else do we have? Oh, we have a ferrite core like this. This is actually a core of 5 centimeters long, and if I'm not mistaken, it has a maximum diameter of 7 millimeter. Okay, so this is also part we're going to use, and then we're going to use this wire here. Okay, and this wire is as close as I could get it for a reasonable price, that is, to a 30 gauge. So 30 gauge enameled copper wire, or let's say close to that. In millimeters, that would be 0.2 mil, as you can tell over there. Okay, so we have all the parts to build our tuner. So what we're going to do next is place all the parts on a breadboard, and then we'll start winding our receiver coil. Alright, I assembled most of the tuner and of a very small amplifier over there, of which I'll show you the schematic, not to worry. And I'm getting ready to turn a spool for the antenna of the AM radio, and I am using a little trick to do that. So this is the 30 gauge wire that I'm going to use, and I'm going to wind about 70 turns of it on this ferrite rod you see here. Now obviously I need to keep the wire in place, so as I'm winding it, but also afterwards, I don't want the wire to unravel or unwind from the ferrite rod. So I'm using a little trick, which I think I've found, but it's quite possible, since it's so logical, that other people have used the same trick somewhere. I'm using double-sided tape, but not just any kind of tape, but the kind of tape they use to glue, say, carpet or even PVC to the ground, yeah, so that it doesn't slide or move around. And that is actually, if you look at it, it's very, very, very thin fabric. Let me see if I can, there you go. So you see, it's very thin fabric. So hardly, oh, I would say 1/10 of a mil thick, and it's very sticky. So what I'm going to do is I'm going to wind, and I stuck 2 pieces. You see, the ferrite rod has 2 flat sides. So I stuck a piece of double-sided tape on each of the flat sides. So what I'm going to do is I'm going to peel off this protective layer here, and then I'm going to wind by hand 70 turns of enameled copper wire, very closely packed together, one after the other winding. And I'm going to put around it about 70 windings. Now, the specifications for the ZN414 or the TA7642 say that you should make a spool of about 55 turns. Now I'm going to make one of 70 turns. If it turns out there are too many windings, I can still unwind a few. If I would make it 55 and it turns out I would need more windings, well, that would be a lot harder to do. So I'm going to do, in effect, the reverse. I'm going to wind more windings than technically needed, and then I'll unwind some turns if needed to fine-tune the antenna of the radio of the tuner. Okay, so that's what I'm going to do next. I placed all the components on a small board I cut, and by the way, I cut the perfboard with a coping saw, which you know, for just one little piece is just the right tool. So I laid out all the components that I will use to make a small tuner module, and I think I'm rather satisfied with the layout of the components. So what I'm going to do now is I'm going to solder all the parts in place, and then I'm going to connect up the coil and the tuning capacitor. Well, and here is the little tuner module finished. And I found, I think, the right placement for all the parts. So I'm rather pleased with it. Of course, as they say, now comes the proof of the pudding. And as we all know, the proof of the pudding is in the tasting. So what I'll need to do is to test this little tuner module and see whether it will work or not. And this is the underside. I still need to clean off the solder residues. Yeah, but it looks rather neat and simple. Yeah, so I'm rather pleased with it as it is. So yeah, well, let's try the module out and see whether it works or not. Okay, just as a proof to myself and to you guys, I wanted to show you that the tuner really works. I don't know if you can hear it. The sound is rather faint, but it is picking up a signal from my heat kit high frequency generator you see over there. Okay, so it's putting out a little bit less than 1100 kilohertz. Okay, so let's say 1.1 megahertz, and it's loosely coupled to the antenna rod via this little coil. Okay, so it goes all the way up to here and into the antenna rod. Yeah, but it's loosely coupled. There's no electrical contact between the spool wire and the high frequency generator. Okay, so in any case, the signal is pretty weak, which I'm pumping in, but as you can hear, it still receives the signal. I'm not going to go into detail just right now. I just wanted to show you that it does work, but it turns out that the coil, the reception coil you see here, is really rather critical for a good reception. So what I'm going to do now is I'm going to use all sorts of coils. I have a whole bunch of them lying here, and I'm also going to use all sorts of ferrite cores and see which sort of coil might give me a better result.
Chicken and the finest white paint from his dark yellow silver. He then blended it with a pinch of soda and shaped it using an army of bronze slaves. The end?
Well, not quite the end. Chicken was planted to actually make 100% chicken breast meat. A very simple no-tail. You might want to discern how to tender the onion.
The radio is quite fiddly, and as you can tell, it's quite sensitive to all sorts of parasitic signals. But it works. You can listen to sound. Now I'm trying not to find music because I don't want to risk a strikeout from YouTube. Obviously, it's not a powerful 100 watt stereo or anything like that.
They've got to be perfect. Bessie's Roasters. The roast potato rated by multimeter. Real music matters.
Hey, good morning. Thank you very much to Ben Burrell for sitting in for me last
So you won't wake up the neighbors with it, but I suppose if you build this into a tiny portable radio, it will work quite well. The quality of the sound is, all in all, is not too bad actually for such a small radio. Okay, I switched it off because I really don't want to risk getting a strike from YouTube. Anyway, before I start to explain exactly how the radio is built, there are actually three main parts on this tuner design, you could say, that are important for you, my viewer. And the main part, which is quite obviously the tuner, is this part here. You see it's connected to my homemade coil, which is this one here on a ferrite rod. It's a 5 centimeters or 2-inch ferrite rod. A small tuning cap, which goes, if I'm not mistaken, up to 220 picofarad. And they are connected via connector pins to my little tuner setup here, which is actually nothing more than a small perfboard PCB on which I built the tuner with some spare parts. And of course, if you look carefully, you see down there, you see the well, you could say the receiver IC. Okay, so this IC is actually a TA7642 and not a ZN414. But more about that later. Next to the tuner, you have this little setup here. And this is actually nothing more than a variable power supply, which can deliver a voltage between, say, a half a volt, so 500 millivolts, and 1.5 volts. Somewhere in that range you can set a certain voltage, and I will explain again in a few minutes why that voltage is so important. And then you have the last part of the circuitry, which is this part here, and that is the amplifier. And the amplifier is built around a TDA 2822 chip or IC, and you can see the IC right there. Let me show you a close-up of it. There you go. So built around that tiny IC is a amplifier, and theoretically the amplifier can go I would say up to about a watt in power, in music power, depending of course on the supply voltage you put into it. But anyway, so that's about that. So you have three parts to the whole setup, which is the amplifier, you have the tuner or the tuner module, and you have a tiny variable power supply over there. So now this is a close-up from the tuner module, and as you can see, there are really only a few parts that make up the tuner module. So a few capacitors, a resistor, a variable resistor, and of course the IC itself, which is hidden behind that big capacitor. You see it right there. So let me explain to you first the main part of the design here, which is the tuner. And as I told you, the tuner is built around a TA7642. So one or two details that are important to mention. As you can see, I built the radio on a breadboard, and I'm using a lot of wires to do or to connect up all the parts of the tuner or radio. And obviously for testing purposes or to build a proof of concept, that's fine, although it has its limitations. And one of the biggest limitations this kind of method has is that, first of all, the contacts on a breadboard are not really very good, meaning that you can never have a really very good electrical contact using these. Second, you need a whole bunch of wires to connect up all sorts of parts with each other. And obviously, the more wires you have cluttered like this, the more or the greater the chances are you're going to pick up some stray signals. Well, I would mean parasitic signals, crackling and buzzing and all that sort of stuff. So really using a breadboard is good to, let's say, test a concept, but I wouldn't recommend building something really critical on a breadboard, and especially not something high frequency. Now this still works on a breadboard because we're working in a relatively low frequency band. So I'm talking about broadcast or the AM band. If I were to build something that would work higher up in the megahertz bands, you know, like shortwave radio or FM or something like that, then breadboard would really not be, absolutely not recommended. Right, another interesting thing to note is that as a power source I'm using a lithium-ion battery, or rather a battery pack. You can see it here, and I don't know if you can see this, but it's a 7.4 volts 2800 milliampere hour battery pack. It's quite good. I'm quite happy I have it, and I've been using it now for a few hours already, and it's still playing with this battery pack, so that's really perfect. Mind you though, this is lithium ion, and lithium ion packs are, let's say, notorious for starting to burn. I don't have to tell you that, well, let's say about a year ago there was quite a bit to do about a certain brand of smartphone spontaneously catching fire. Well, one of the reasons why they caught spontaneously fire is because they were using lithium-ion batteries. Now, if you use these batteries correctly, so you don't shorten them, you don't put them in a hot spot, you know, under the sunlight or something like that, then you're safe, okay? And obviously you shouldn't overload these either. And that will be one of my next weekend projects, showing you how to build a lithium-ion battery pack charger. Okay, so you shouldn't overcharge these. You shouldn't put too heavy loads on it. You shouldn't shorten them, nor bend them, nor stab them with a screwdriver or anything like that. So as long as you keep the battery pack intact and cool, relatively cool, you're good. Right, the next thing I want to show is the speaker. Now, you remember that in the beginning of the video I showed you a tiny little speaker, a 4 ohm speaker, which was about half the size of this one. Now, although the circuitry worked with that tiny little speaker, the volume of the sound was really weak. So the size of the speaker does matter. So if you're going to build this circuit with the same components, what I would advise you is that you buy a 2 or 3 inch speaker like this one, which is, by the way, 8 ohms and about a watt in it's rated for about a watt of music power, okay, so sound power. And I would advise you to use one of these, not those tiny ones. They are good, those small ones are good for quickly testing out whether you're getting sound or not, but really, if you want decent sound, use one of these. Right, so that's about the, let's say, the interesting details. Now let's get a closer look at the electronic side of the tuner. Okay, the first thing I'm going to explain is how the tuner was built, and the active part of the tuner, or let's say the nerve center of the tuner, is this part right here. This is the TA7642. Now the TA7642 is not a transistor, but it's an integrated circuit. It in fact contains a lot of, you could say, intermediate frequency amplification and filter stages, all built into the case of one tiny transistor. And that's really what's going to form the heart of our design. And you can hear it crackle and play in the background, but I'm going to switch it off for now so that it's not becoming a distraction to us. Okay, there you go. Right, so what happens in fact is that you have on the left here of the schematic a variable capacitor paired with a coil, and the coil you see on the schematic is really the coil down here, so this coil in fact. Okay, I built this coil myself, and it's really not very complicated. It's a ferrite core of 5 centimeters length and about 7 millimeters diameter, and I wound in fact a number of windings of copper wire around it. Okay, so there you go. So in fact it's not so difficult to make this coil. For just a couple of dollars you can buy a ferrite core and the appropriate wire, which is pretty much like this. Okay, so it's really thin enameled copper wire. Okay, so nothing really special. Like I said, for a couple of dollars you can make yourself a ferrite antenna, because that's really what it is. So this coil is part of a tank circuit, so a circuit which has a certain, let's say, how would you say that? It's in resonance with a certain frequency, or in our case, a number of frequencies which range somewhere in the AM band, so in the broadcast band. Anyway, this assembly here will pick up radio signals which will be sent into the chip via pin 2. Now remember, this is not a transistor, okay? So pin 1 is connected to ground, pin 2 is the input, and pin 3 is the output of the integrated circuit, which just happens to have the shape of a transistor. So don't you make the mistake of considering this to be, you know, like, I don't know, collector base or emitter or something like that. No, forget about that. Okay, anyway, so to return back to our story, the coil variable capacitor assembly is connected to pin 2 of the integrated circuit. In other words, the coil picks up some signal to which we tune with the variable capacitor, and then via a number of circuits within the integrated circuit, the signal is filtered and amplified and all that. Really, if you want to know more about how exactly the integrated circuit works, then you better have a read of the TA7642, or alternatively the ZN414 integrated circuit, and you'll understand a little bit more about the internal workings. In effect, this really amplifies and cleans up the AM signal it receives. Okay, so this is sent out, the cleaned up and amplified signal is sent out via pin 3, where it is filtered a little bit with this capacitor you see here, and then is sent through a variable resistor, or a potentiometer if you prefer, through a electrolytic, which stops any DC component in the signal, which might be in the signal, from passing, and therefore you get a low frequency or audible signal which leaves right here, so out of pin 3 via the capacitor mainly and outwards. Now the signal is very, very weak. You could hear it if you use an earphone or something like that, but I tried, and even with an earphone it's quite weak, so don't expect much of a signal here. I tried to measure it, and as far as my meter is accurate, I would say the maximum AC I got out of it is about 20 millivolts. But my meter is not an RMS meter, so I couldn't really tell you exactly how much signal comes out of it, yet it is very, very weak. So we will need in the end to amplify the signal which comes out of pin 3, really, without of course introducing all sorts of stray signals and noise into the output ourselves. Yeah. Now all the parts you see here are parts that really I had lying about, except of course for the TA7642, which I bought recently. The parts themselves are not too critical, but obviously the better quality they are, and the, let's say, the shorter the leads are between the TA7642 and the other components, the less noise you'll have and the more sensitive and selective the tuner will be. As you can see here, when I built the module, I really built it very, very compact. Well, of course, compact in the sense that I used off-the-shelf parts which are all soldered onto a perfboard PCB. I guess you could make it extremely compact if you used SMD components, so surface mounted components, but my goal was to build something which anyone could build with a little bit of handiness and patience. Okay, so I also built some tiny connectors which allow me to use perfboard type of wiring, you know, something like this. Okay, and the goal of that was to be able to switch out the coil, for example, for another coil, to see whether I could improve the reception or maybe even change the band of reception by using another coil. Also, the variable capacitor you see here is really nothing special. Okay, it's just a tiny little variable capacitor which I had lying about somewhere in one of my drawers. And it goes, I think, all the way up to 220 picofarads. So from, I guess, somewhere around 30 picofarads to 220. And it works perfectly. It's really a cheap little tuning capacitor, nothing special. The only thing that you have to mind is that you pick out a good core, a good ferrite core, and the right type of wire for making the coil. Okay, so I bought 0.2 mil diameter enameled copper wire. It wasn't too expensive. I bought a whole roll of it. I think a roll of 30 meters or so of it. And it turns out I had to wind about 53 turns of the copper wire. And that turns out to be just right for, at least for my setup, to pick up the AM band. Okay, so moving on. The special thing about the circuit with built around the TA7642 is that it really has only 3 pins, which means that if you have an input, a signal input, which is pin 2, and a signal output, which is pin 3, and only 1 pin for ground, where does it get its voltage from to work, right? You need some sort of voltage to make it work. Well, it turns out that you need to inject DC voltage via the output pin into the integrated circuit. They call it AGC, or automatic gain control voltage, although I would not exactly call that. I would rather say it's just a supply voltage which you can vary between, roughly speaking, 0.5 volt and 1.5 volts. Yeah, it only needs maximum 1.5 volts. Don't forget, because if you inject more than say 1.5 volts, you really risk ruining this integrated circuit. Normally the specs say that you could go to 6 volts. Well, I'm not entirely sure that the chip would be able to withstand it, and frankly I didn't try. So you're free to try and see whether that substantially changes the working of the chip. Maybe it might amplify its output signal a little bit more if you inject more voltage into it, but I don't think it would survive very long, because it would get, well, my guess, it would get really hot, and the hotter a component, the shorter its lifespan. Right, so like I said, you can inject a DC voltage into pin 3 of the integrated circuit. And that DC voltage has really two functions. One is to obviously make the internal amplification and filter circuit work, but also to make it influence the gain it has in high frequency signal. Okay, that's why they call it automatic gain control voltage. I'm not sure it's really automatic, but it is a fact that when I vary the voltage here, anywhere between say 0.8 volts and 1.6 volts, it seems to be more or applying more or less amplification to a signal. So it definitely has an influence on the working of the chip. So to be able to vary the amplification, or like they say, the automatic gain control of the chip, you need to build a tiny power supply, which is depicted here. And really what this is just a kind of variable power supply, nothing more. And with the help of a variable resistor, so a trimmer, you can set the output voltage, which you will inject into the tuner output pin. I used a MultiTurn trimmer. Let me see if I can show you. Okay, so that trimmer there. Okay, so this is the trimmer I used. Okay, it's a multi-turn trimmer, 50K, nothing special, and the reason why I bought a multi-turn, or rather used a multi-turn resistor, is because that allows me to very accurately set the voltage, the output voltage, via this pin here. And it works nicely, and indeed when I vary the resistance via this trimmer here, I can vary quite nicely the output voltage here between say 0.7, 0.8 and 1.5, 1.6 volts. Now critical is that the voltage, the supply voltage of the power supply itself, is somewhere between 7.4 and 9 volts DC. Because I experienced if I used lower voltage, well, the circuit doesn't really want to work that well. And also, since I'm feeding also the amplification of the sound via my power source, well, I do need a little bit of oomph to be able to amplify the signal. So I use the battery, which is normally around 7.4 volts, or a lithium ion battery, which you see there. Okay, a rechargeable lithium ion battery, but I guess you could use a 9-volt battery as well, and that would work just as well. Right, so we have the tuner explained, we have the variable power supply explained. So we come to the last part of the schematic, which is really the amplification of the sound. Now, for the amplification of the sound, you could use almost anything. Okay, so I just happen to have a whole bunch of TDA2822 chips lying about, and I was just wondering what I could do with one of those. So it turns out the TDA2822 is an amplification circuit, integrated circuit, which allows you either stereo or mono output. Now, inside the chip are built really two tiny amplificators, okay, and you can use them separately, so for a left and a right channel, or you could bridge them together. So in effect, you can tie them up to each other and use them as one mono amplifier, which is exactly what I did. Okay, so I'm using the TDA2822 as a mono bridged amplifier, and you see the schematic over there. There's really not much to say about it. The only thing I have to say is that while it is working, the chip gets really warm. I would even say on the verge of burning hot. You can just about touch it without burning your finger, but it's really painful. Now, I wouldn't be astonished, or rather I'm not astonished, the chip gets really rather hot, because it technically can amplify up to 1 watt and draw close to 1 amp of current. Now, if you put that much current through a tiny chip like the TDA2822, so that little chip over there, okay, so that's an 8-pin dip integrated circuit. So if you're going to put that much current through such a small chip like that one, well, you shouldn't be astonished that it gets hot. Anyway, what can I say about the amplifier? Well, to make the amplifier work correctly, the components are not too critical. Actually, they're not critical at all. I just use components I had lying about. Let me see if I can show you the components list. There you go. Okay, so these are the parts that I used. Nothing special, really not. It's standard components, but well, like I just told you, the integrated circuit can become quite hot. Also, if you read the specifications of the integrated circuit, it seems you can feed it anywhere from plus 5 volts to plus 15 or 16 volts DC without any problems. So, but since I wanted a reasonable amount of power, audible power, I'm feeding it via my lithium-ion battery, which can supply all the way up to 2.8 amps if really needed. Okay, and supply 7.4 volts. Anyway, all the parts you see here are standard parts. I did not use anything special, no special parts that you need to buy somewhere in some specific shop or anything. All the parts you see on this list are freely available off the shelf. I think the total cost without the battery and the speaker is somewhere around $10 for the whole setup. If you're going to buy a speaker like the one I used, so that one over there, okay, that will set you back, say, by another $2, $3, maybe even $4. And the battery, well, that was probably the most expensive part of the whole design. The battery cost me somewhere around $12, if I remember correctly. So, yeah, well, if you count, say, $3 for the speaker and $12 for the battery and $10 for all the other parts, that would bring it up to $25. So I would advise you to look around and maybe you can find a cheaper alternative, for example, to the lithium-ion battery I am using. Anyway, what I want to end up saying is that I did build this partially out of curiosity. Okay, I wanted to know how the reception works. Okay, if you use I wanted to see how a ZN414, or in this case an equivalent TA7642, how it works. Okay, so that's why I built this little setup. I wanted to build an AM radio out of it and see how well it works. I can't say I'm blown away by its capabilities. It's not extremely selective. It's not extremely sensitive. Obviously sound quality isn't comparable to FM quality, but well, hey, since we're working in the AM band, that's normal. So yeah, well, what can I say? It's interesting to do it anyhow, because it taught me a lot about how to work with sensitive stuff, high frequency stuff. And let me tell you, this design is really sensitive. It will react to whatever source of noise or signal is around it. Okay, so that in itself is already very annoying. I use a breadboard to set it up, and originally the little tuner I built around the TA7642, so this little board here, Originally I had the parts you see on the board all set out or laid out on my breadboard, and I'm going to tell you honestly, that doesn't work. It doesn't work. The only thing I kept picking up was buzzing and crackling and just all sorts of noise, but no radio. And if you read the specifications for the TA 7642, they clearly state in the data sheet that you should keep the leads between the TA and the other parts as short as possible. That's why that's also why I built such a tiny little perfboard design, because I wanted to keep the leads as short as possible. Okay, so that's why I built it that way. Right, what else can I say? Well, you do need a little bit of patience to get it working. So what I did actually was I built my little tuner first, which you see here, and the little tuner you see here is really exactly the same as I wrote down in the schematic, okay? But it's the tuner and nothing but the tuner. I then built the little variable power supply, or the AGC voltage supply, on the perfboard. And then lastly, I built the amplification stage, which is over here. Now, the way how I tested all of this is quite simple. So I built the AGC power supply first, and I hooked up my multimeter to its output. And then by varying the small trimmer pot you see over here, so this one here, okay, I watched the voltage on my multimeter change, and I was rather satisfied by what I saw. So the voltage varied somewhere between 0.5 and a little bit less than 1.8 volts without a load on it. Okay, so without load you will always get a little bit different voltage. Right, so like I said, then I built the little tuner which you see here, and then I built the amp stage over there. Now, instead of jumping in right away and testing the the tuner, I tested the amp out first. And so I built it up on my breadboard. I connected it up to my battery, which you see here, okay. And I injected a signal into the input of my amplification stage, which with my, let me show you. Okay, so with this is a small signal generator which I use normally to detect wiring in network wiring. Okay, so with this I can inject a signal into twisted pair cabling and detect which wire is connected to which signal, let's say. And the advantage is it also has a simple, well, audio output signal which I can inject into a wire with those crocodile clamps. Okay, so I injected with my signal generator, well, with my cable tester, really, I injected a signal into the amp stage, and when I was satisfied that it would work correctly, I finally hooked up my power supply to my tuner and my tuner to my amp stage. And then I fired it up. Now, it would be really nice for me to be able to say, oh, you know, I just hooked it up and it all started working right away. You know, forget it. I had to spend really, I'm not exaggerating, but I think I had to spend about 2 hours to get it to work. And the main problem is the coil, really. So originally I had about 80 turns of copper wire on my ferrite core, and with 80 turns I really got nothing, absolutely nothing. Okay, so except maybe for some crackling or whatever, I really got no signal at all. So what I started to do was I started to unwind excess wire, say 10 turns a pop. Okay, so I unwound 10 turns, I shortened the wire, kind of reconnected it and tested it on my receiver, on the little tuner you see over here. Okay, so I unwound 10 windings at a time from the core until I started to get somewhere around 55 turns, and I started to get very, very faint signals, but really very faint. And since my hearing isn't too good anyhow, you can imagine I had quite some trouble hearing it. But hear it I did, and I slowed down and I started to unwind it, not by 10 but by 2 turns. Okay, eventually I unwound it to 48 turns. Excuse me, but then the reception became worse. So I rewound the wire back up on the core until I got to 53 turns. And at least for my design, that turned out to be just right. 53 turns on that ferrite core. Okay, if you're using a different ferrite core, you might also have to use more or less windings than I did. Right, so well, that's it. Now the very last thing I should tell you is that while I set up my radio to test whether it works or not, I also hooked up the AGC output of my power supply. Yeah, I hooked that up to my multimeter to keep an eye on it, and I'll show you now what I mean by an eye on it. Okay, right, so you can hear the radio crackle in the background. So if I turn the variable capacitor, you see the voltage of the AGC controller or the AGC power supply vary with the tuning. Okay, now I did notice that when I do get a maximum signal, the voltage of the AGC drops to a minimum, which is pretty weird, but that could be useful to to detect something. Okay, you can hear a radio now in the background. But you see, as soon as I untune the radio, the AGC voltage jumps up. Okay. As soon as I get close to the signal of the radio, the voltage drops. When I detune the radio again, the voltage rises again. So you could possibly use that to measure the field strength of a radio signal. So that could be an interesting feature. And I might even play with that in a later design to see whether I could use that for something, to build something. Anyway, this is how I kept an eye on the working of my tuner, and it's really rather accurate. So yeah, well, there you have it. And that's the little AM tuner I built around the ZN414 or equivalent, the TA7642. I hope you enjoyed this new weekend project, and I'll be on soon with another project for all of you, or even a new restoration. So I'll see you all soon, and thanks for watching.